You know that feeling, right? Your phone just dies. It's completely dead. Feels like a total mystery. But what if I told you that bringing it back to life is actually less about super technical stuff and more like a fascinating detective story? Yeah, for real. So let's dive into that. So, your phone is dead. What happens now? You've tried everything, right? You've charged it, you've held down the power button for what feels like an eternity, and nothing. It's a total brick. So what happens next? Well, when that phone lands on a repair technician's desk, that's when the real investigation begins. The victim? Your phone. And the crime scene? Well, it's one of the most complex pieces of tech you own. So, where does our detective start? Section 1. Inside a dead phone. The first place they look is the motherboard. You can think of this as the brain, the central nervous system of your phone. Literally every single thing. The screen, the camera, the buttons, it's all controlled from right here. And when that motherboard fails, that's when a technician basically becomes a detective. I mean, look at this. A motherboard has thousands of tiny, microscopic components all packed together. It's like a super dense city. And just one single failure in any one of them can cause the whole system to just shut down. So the tech's job? It's to search this entire city, piece by piece, to find that one faulty part. All right, Section 2, the visual detective work. Just like any good investigation, you gotta start by surveying the scene. Before plugging in any fancy tools, the very first step is just a careful visual inspection. You're looking for the obvious clues, right? Anything that screams, hey, something went wrong here. And this is the initial sweep. It's super systematic. First, you check for any physical damage, cracks, burns, anything like that. Next, you inspect the connectors and slots, basically all the parts we plug stuff into. And finally, you test the main voltage supply. This answers a really, really simple but crucial question. Is this thing even getting power in the first place? And what are they looking for? Well, you're looking for these visual clues. Think of these as the electronic version of fingerprints or a footprint left at the scene. A technician is hunting for anything out of the ordinary. A tiny crack on a component, a little black spot that looks like a burn, a pin on a connector that's just a little bit bent. You'd be surprised how often the clue is just sitting there, in plain sight. So now we get to the first real test. Does the power connector actually get those 5 volts it's supposed to? Using a simple tool, a multimeter, they check if the power from your charger is even making it past the USB port. If it's not, boom. You've just narrowed down the search from thousands of components to just a few, right at the very beginning of the circuit. That's a huge win. Okay, Section 3, identifying the usual suspects. So, once that initial sweep is done and there's no obvious damage, the investigation moves to the next logical step. You gotta question the usual suspects. And believe me, in the world of motherboard repair, there are definitely a few components that are just notorious for causing problems. And here they are, the most frequent failures. You can think of these as the most wanted list. First up, you've got the power and battery connectors. I mean, they take a lot of physical stress from plugging and unplugging. Then you have the physical switches, like your power button, that just plain wear out over time. And then there's the big one, the power management IC. This little guy is like the traffic cop for all the electricity on the board. If it goes down, everything just stops. And the crazy part is, the damage can be so subtle. A switch might fail because of bad soldering, or a battery connector's pins could be cracked on the inside, totally invisible to the naked eye. A component can look perfectly fine on the outside, but be broken internally. We're talking about a tiny, invisible crack deep inside a solder joint, and that's all it takes to bring the entire phone down. This is where the detective work gets really tricky. Which brings us to Section 4, the IC and capacitor trick. So what happens when there are no visual clues? When all the usual suspects seem to be fine? This is when technicians pull out a really brilliant diagnostic trick. It's a clever bit of deduction that can reveal a massive clue about the board's health. But first, we need to know what we're talking about. An integrated circuit, or IC, is one of those little black squares you see on the motherboard. You can think of it as a chip, and it basically acts as a mini-brain for a specific function, like managing power. There are dozens of these, each with its own job, and they are absolutely essential for the phone to work. But here's the problem. How do you test a complex chip like that? I mean, it can have hundreds of connections. Testing it directly is pretty much impossible unless you have the manufacturer's full schematic, which is rare. So how does a detective figure out if one of these tiny brains has gone bad? Well, they use this really clever workaround. Instead of testing the super complex IC itself, they test the tiny little capacitors that are right next to it. So here's how it works. Normally, a capacitor should only be connected to ground on one side. That's the normal flow. But if you test it and find it's connected to ground on both sides, that's called a short. It means the electricity is taking a shortcut it's not supposed to, and that's what's causing the entire system to fail. And here is the truly brilliant part. In about 90% of cases, yeah, 90%, that shorted capacitor isn't even the real problem. It's just a symptom. The real culprit is the big, complex IC right next to it. So that one simple test on a tiny little capacitor becomes this incredibly reliable way to know that the chip itself is bad without ever having to test the chip directly. It's genius. Here's a great way to think about it. Checking an IC by testing its surrounding capacitors is like checking the health of an organ by monitoring the blood pressure in the arteries nearby. You can't see inside the organ, right? But if the arteries leading to it are completely blocked, you can be pretty sure the organ has failed. It's just an elegant piece of electronic detective work, using a simple clue on the outside to figure out a complex problem on the inside. Okay, let's move on. Section 5, replacing the broken parts. So our detective has found the culprit. The case is pretty much cracked, but the job is not done yet. Now comes the final delicate step, replacing that faulty component with microscopic precision. And this isn't as simple as just grabbing any spare part. No way. The rules for replacement are super strict. For things like ICs and processors, you must match the reference number exactly. For simpler stuff like capacitors or diodes, you might get away with just matching the size and shape. But for the brains of the operation, it has to be a perfect identical match. So, in the end, the solution isn't just about finding the broken part. It's about finding it and then replacing it with the exact right piece to complete the puzzle. Bringing a phone back from the dead really is a two-part challenge. First, the logical deduction to find that one single point of failure among thousands, and then the technical skill to replace it perfectly. So, is a broken phone a total disaster, or is it a complex puzzle just waiting to be solved? The next time your phone goes dark, just remember what's really happening behind the scenes. It's not just a broken piece of hardware. It's actually a complex mystery. And somewhere out there, a technician is playing detective, hunting for clues to bring it back to life.